So, just a quick recap. What we did yesterday was, well, a lot, as you could see in the table, but we had to figure out the z-score for each one of the x values and each one of the y values corresponding to their given sets. All right. So basically, what we're looking for is a deviation in terms of the standard deviation, like how far each individual value is away from the mean in terms of the corresponding standard deviation for each variable. All right. And so the product of those two deviations give you a squared deviation. All right. So that's what that last column gives you. And I mentioned that I would talk to you about where all this stuff is coming from. It's kind of a class period in and of itself, but it's interesting stuff, so it's worth talking about, but at a later point. All right. So if I want to figure out the correlation coefficient, I would need to take the sum of all of the entries in that last column. And right now we're going to find out if I accidentally deleted all that data from yesterday. Stat, edit, thank the maker.
Yay.
It's all there. All right. So, time saver. All I need to do is get the sum of the values in L5. All right. So, second, stat, math, option 5, and then type in L5, second 5. All right. So, this stuff ended up in L1. I'll just kind of jot it at the bottom. This one was in L2, L3, L4, and L5. So this entry here, again, is the sum of all the entries in L5. All right? Which is that number. All right? We multiply that by 1 over n minus 1. N is the number of pairs of data. All right? So n is the number of pairs that you see in the original data set. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pairs of data. Oftentimes that's just given in the framework of the problem. It'll say things like calculate the correlation coefficient for 10 randomly selected individuals, so it'll be a giveaway in the problem. But we're taking 1 over 10 minus 1 multiplied by that approximate value of about 8.332. Oh, I wrote n, I meant r, because that's our n value. And the result, so what I would just do is, it's the same as dividing by 9. Take that, divide by 9, and you get about 0.926. All right. All right, so that's a tabular approach. And you are going to need the table method, even on the AP. You're not going to have to actually produce the entire table, but you'll have to have a sense of the formula, because even multiple choice questions often refer to the formulas themselves. Now, the formulas, you saw on the last test, they're graded and ready to go. I just need to have everybody who needs to take the test in order to release them. But just more on that later. But we'll get there. Anyway, on the AP, you get reference sheets, just like on the last test. So you're going to have the formula. It's just a question of, do you know what all the entries in the formula represent? Right? That's a different story. All right, but we'll get there. Linear regression is based off of the correlation, right? Because correlation is talking about the deviation of each point from its established mean for the data set. Right? So it would make sense that if we minimize that deviation, we're going to get some sort of accurate representation of the overall trend. And that representation would be in the form of a linear function, right? Ideally. Right? Sometimes it's other types of functions, but not necessarily. Right? Ideally, we would go for the linear. So we have two formulas that we use here, and all this information is stuff that we have at this point. Right? Now, what I tend to do is, if I have to do this by hand, I save this and I store it in as something. R, for example. It's just annoying that I got to use a capital R here, but it's lowercase r on paper, but that's all right. Can live with that. It's just kind of a placeholder anyway. So I need the ratio of the standard deviation, sample standard deviation for the y variable to the sample standard deviation in the x variable. All right, multiply that by the correlation coefficient, and you get your slope. All right. So that's what we're going to do. But I'll just jot this information down. We have, what was it, 0.926 approximately. So the b value is going to be 0.926, but we want the most accurate form of this, the ratio, and just got to go back and grab those. We're talking these two numbers, just in the reverse order, so I'll just have to do that. So, beep. All right, but vars 5 option 6, for example, I just type it in, you see it calls up, well, I haven't used my calculator to do any statistical analysis between yesterday and today, so all the stuff that we did with the 2 variable statistics is still locked in there. If not, then just run it again, stat calc option 2, make sure it's referring to the right data set, L1, L2, and it'll automatically store these values in for SX, SY, X bar, and so on. All right. So when I want to do this, I know I already stored my R value. So I'm going to multiply that by the ratio of S of Y, so 6, vars statistics option 6, and then vars statistics option 3. And that'll give you your slope of about 0.0916. All right. Now, in terms of the Y-intercept, that's Y bar minus B times X bar. So I'm going to store this in for B, and I'm going to grab Y bar, so vars option 5, choice 5, or option 5 again, right, minus the B value, alpha B, times X bar, vars option 5, option 2, and I'm going to get about 1.307. All right, so we're looking at, again, the Y bar value. I mean, I can just grab it from up here if we're doing it by hand, 2.9 minus the B value, 0.916, times the X bar, 17.4. That's going to give me approximately 1.307. But all of this stuff here gives us the values in the most accurate form. All right, that's really what we want. So, but in the end, you're going to do some rounding anyhow. As long as you know 3 significant digits, just save it for the end, you're in good shape. All right, so y hat is equal to a plus bx. I'm sorry. Oh, yeah, no, I'm right. The calculator gives it in a different way. Different textbooks give it in a different way. We use a plus bx. The y hat represents a predicted y value. Right? So you kind of think of it as sample versus population. So anytime you have just a letter, in statistics anyway, anytime you have a letter without any kind of accent to it, so a hat or a bar or whatever, it's just talking about a population measure, just in its most general form, right? So y for all values of y. Throw an accent on it, now you have something else. So a hat represents it on the sample level, all right? So this is related to the given data set, which you could then use to project out and draw conclusions about the population if your sample is representative of the population. Goes back to what I was saying yesterday where if you want to draw conclusions about the senior class, but you only poll freshmen, that's not going to be a representative sample. Right? So you might get a linear regression equation. It might look great, might have some nice numbers, but it's not going to be anything that you could use to draw conclusions about the population. So in this case, we're looking at y hat is equal to 1.307 plus 0.0916 times whatever the indicated x value is for all values of x, because it's a linear equation. However, there would be some domain restrictions because of the context of the situation. Context always trumps any calculation. All right. Now, just as a reminder, you've seen this before, definitely in years past. If you go to Stat, Calc, and look down the list here, you see all these different regs. Every reg represents a regression. All right. You might see the linear regression here, AX plus B. That's the one you probably used in the past. We're going to use option 8, lin reg. And in fact, in the past, and I can even say before I taught a stat class, because when I took stat, I mean, it's at the point now where it's almost like so ancient that it's an apples and oranges conversation. It's like there's no context for relation. You know, like a fax machine is kind of like the line of demarcation between like prehistoric technology and what we have today. So I was learning this around the time of the fax machine, which means I did all this stuff without a calculator. But when I started teaching, I didn't teach stat initially. So I would look at this and see option 4, option 8, 2 lin regs. What the hell's the point of that? Why do you have 2 of them? Yeah, one of them's AX plus B and one of them's A plus BX. Why does that matter? They were just kind of pandering to the different branches of mathematics. Right? When you study linear equations in an ordinary algebra class, you learn y equals mx plus b. I guess they couldn't bring themselves to put an m in there, but whatever. So they structured it that way, ax plus b. But in a stat class, or actually any applications course, we tend to think about the fixed quantity first. Right? If you're thinking about a linear relationship, you're thinking about what is the fixed quantity, and then what do you make in terms of, you know, like if it's a salary, for example, maybe you just got hired for a job, you have a signing bonus. Right? You want to know how much you're going to make over 10 years. You know that you're going to make $100,000. I'm keeping it low. You know, hopefully, I mean, this day and age where we live, hopefully that's the low end of what you would make. $100,000 a year, but let's say you had a $50,000 signing bonus. All right. So that $50,000 is a one-time payment. That's a fixed quantity. But then you have plus 100,000 for every year, so 100,000x. It makes sense to start with the fixed quantity and then go to the variable quantity after that. All right, so that's why the option 8 exists. We're going to use that because that's how the AP exam does it. That's how statisticians do it. All right, but your tendencies might take you towards number 4 more frequently, but I'll have you looking exclusively at 8 before the course is over. All right, X list, Y list, L1, L2, frequency list. We didn't put in any frequency values. People have gotten confused by that in the past because, you know, you can put frequencies into L2, but when you're dealing with bivariate data, L2 is not the frequency counts for L1. L2 is a unique variable. But what this allows for is a frequency list that would well, I'm going to use the word allow again, but allow for repetition of the entries in your X and Y list. Right? So let's say in this data set here, let's say this first entry, 0, 1, let's say that occurred 10 times. So in L3, I would type 10. If 3, 2 occurred 5 times, I'd type 2, and then I'd put frequency list L3, right on down the line. All right, there has to be an agreement between all lists of data. right? Meaning the number of entries in each one of these fields has to be the same. All right, so L1, L2, L3 have to contain the same number of data, otherwise you're going to get an error. Very important. You may not have done this in the past. Store regression equation is going to be hugely important. All right, the way we store it, alpha trace option 1. All right, we want to store it into Y1. Alpha trace is the way to do that. If you have one of the older calculators, a TI-83 or a TI-84 with some of the older software, you select vars followed by Y vars followed by function, and then you'll see Y1 there. All right. It's weird. I can't remember my schedule for the day, but I can remember stuff like that. Priorities, I guess. Calculate. A value rounds to 1.307. B value rounds to 0.0916. You'll see here I have R squared and R. The R value is 0.926 rounded. Right? If you don't have an R squared and an R when you do this, right? If you're following along now, you can verify it very quickly. If you check it out later, you try it on your own and you say, I got the A and the B, but I don't have the R's, it means your diagnostics aren't on. All right, so that would be mode. Scroll on down to diagnostics. Stat diagnostics. You'll have two options, off and on. For whatever reason, the default is off. I think I know what the reason is. It's a function of stupidity. The default is the first entry. Like if you reset the calculator, everything on the left side is highlighted. So I have mine in degree mode, but it would normally be in radian mode. So right on down the left column, everything on the left side is defaulted. But for whatever reason, they put off first, then on. That's the stupidity, right? Because everything else, like for example, right below it, on followed by off, that makes sense, right? So they just put these two things backwards, and this was defaulted as the off, right? But we want it on. If you have one of the older calculators, you go into the catalog. I mean, there's another way, but this is the easiest way. Go into the catalog, go on down to diagnostic on. Hit enter, it brings up diagnostic on in your home screen. Hit enter again, it says done. Now when you run your stat calc option 8, it doesn't keep the store regression in there because it doesn't want to accidentally this is actually one thing that it does, it's smart. It doesn't want to accidentally overwrite what you have in Y1 every single time you run a regression. So it clears it out. Alpha trace Y1. Calculate. Again, if you have one of the older calculators, it's vars, Y vars, function, followed by Y1. All right. So then you look at this, you have all this good stuff here. If you go into Y equals, you see that the entire regression equation has been stored in its full glory. If you hit zoom 9, zoom stat, it brings up absolutely nothing. All right, so what did I do? Who knows? Oh, I got to turn the plot on. How about that? I usually have the plot on. That's my excuse this time. So I want to look at the scatter plot on my calculator, and I also want to look at this graph in conjunction with that. So I'd hit second, Y equals, turn the first plot on. I like to kind of live in the neighborhood of the first plot, and then kind of branch out from there. I'll show you some other plots as we go forward. But turn it on, select the scatter plot. All right, choose a mark that makes sense. I mean, I'm legally blind basically, so I just choose the biggest one so I can actually see it, but like whatever one that makes sense. The reason there's 3 is because you can plot 3 sets of data simultaneously. All right, so it makes sense to be able to distinguish one from the other. Zoom 9 will now work where you get a plot of the data and also a corresponding plot of the linear regression model, which is meaningful because if you have the regression model plotted there as an equation, a linear equation, you also get everything that goes along with typing something into Y1. All right, you can get a table of values. you can evaluate the function. All right. Just a refresher, if you didn't know how to evaluate a function on a TI calculator, all you have to do is bring up the variable and use function notation. So let's say, just going back to this original data set, let's say I wanted to determine how many doctor's visits a person who smokes 100 cigarettes a week would have to make based off of this predictive model. I would type in y of 100. Right? Y of 100, like f of x. This is y of x. Right? With the x being replaced with the 100. And I would get 10.46, and then I would round it appropriately depending on the context. All right? So it kind of helps you avoid the whole tabular approach. Right? You could also do some calculus to it if because I know there's some overlap between the classes, but that's a different conversation for a different day. All right? So just became a whole lot easier because all you'd have to do, because the whole table thing, the expanded table, that was for instructional purposes and to get to know the formula. But you're not always going to have to do that. If you just need the answer, it's really just a matter of typing stuff in and having the calculator spit it out for you. All right. So construct a scatter plot. Come up with a linear correlation coefficient, then determine the line of best fit using the 3 methods outlined above. I only went over the 2 methods because I'm saving the 3rd method for another time. All right, so just going to do another run through. Stat, edit. I'm going to clear. It always breaks my heart to clear out all this data. Look at that. It's glorious. It's glorious. Second plus clear all lists. Second plus clear all lists. All right, wipes out everything all in one shot, saves you a little bit of time. All right, hit enter, brings it up into the home screen. Hit enter again, it says done. Now you have a fresh, clean editor to work with. All right, so much simpler data set though, that's nice. Followed by, a much more complicated one after that, so there's a price to be paid for everything. 2, 3, 5, 9, and 11. This one doesn't have any context, and I always kind of look at the contextless situations as being the most dangerous ones, because then you have a tendency to want to round when maybe you shouldn't. You don't know what the context is, so you have to leave it a little bit more open-ended. All right, so you just got to be careful about stuff like that. All right, now we need to run a 2-variable statistics on this. If we're going with the full-blown table, we need 2 variable statistics, and then we need to compute the z-score for each x value and each y value. Using the table is the way to go for that because it's going to do it all in one shot. All right, so quit out of here, stat, calc, option 2. Everything is as it should be. Right on down to calculate. Enter. You have the mean. You have the standard deviation. You have all that good stuff. All right, so now stat, edit, right up onto the column heading. Okay, right up onto the column heading. That's an important piece. People who run into errors on this, they run into the error because they do it in the first cell, not on the column heading. All right, enter, x minus x bar over sx. So the the x value is in L1 minus the x bar value, vars, option 5, option 2, divided by vars, option 5, option 3. All right, so that's what we should be looking at there. Save that for later. Then you hit enter, populates the column. Do it again for L4, except this time with Y information. So L2 minus vars, option 5, option 5, divided by vars, option 5, option 6. All right, hit enter, lock it in. Product of L3, L4. Enter. Now, in order to figure out the correlation coefficient, again, R is equal to 1 over n minus 1 times the sum of x minus x bar over sx times y minus y bar over sy. We have 6 pairs of data, so 1 over 5 times whatever the sum is of L5. All right? So second stat math 5, L5. And we get about, it's 4.9-ish. All right, so pretty close to 5. So I divide that by 5, and I get about 0.999. All right, the B value, R times SY over SX. So I need my SY. So stat, calc, 2. I could go into the VARs option 5 menu, but this is one-stop shopping. So I'm just going to jot it all down here. X bar is 5.167 approximately. Y bar, I'll get that in a minute. SX 4.020, roughly 8. SY, I'll get that in a second. So going down the line here, 10.167, 6.616. All right. So we're looking at about 0.999 times about 6.616 divided by about 4.0208. All right, so my R value, I don't remember if I saved it. I did. Okay, that's good. So R multiplied by the ratio vars 5 SY vars 5 SX. So about 1.643. Then A is going to be equal to Y bar minus B times X bar. I could put some values in there. So 10.167 minus the B value 1.643 times 5.167. So I'm going to save this. I'll store it in as B. So Y bar vars 5 minus B times vars 5 2. So about 1.676. So Y hat is going to be equal to 1 point. Sorry. No, that was right. 676 plus 1.643 times X. And that would be my regression equation. All right. And I could check it, stat, calc, option 8, stored in, alpha, trace, Y1, calculate, get all the good stuff there, double check that it's in here, zoom 9, looks pretty good, consistent with the correlation coefficient, which is very close to 1. All right, now just as a reminder, if you're trying to do this stuff in a different class, like use the Y equals menu, and let's say you type in something like x squared, and you get a nice little scatter plot showing up, it's because you have a plot on. Sometimes you get an error too. That's even more aggravating. What you do is just turn this plot off by hitting enter on that bolded plot. All right, then it'll turn out just fine. So you could toggle it on and off in this menu here. All right, so on, off. All right. This way you still have your settings. It's still set for the scatter plot related to L1, L2, but you don't have to have it when you don't need it.